In recent years, the advancement of machine learning techniques has significantly expanded the scope of problems that can be addressed through computational solutions. However, incidents caused by AI failures continue to raise safety concerns among the public. Therefore, it is critical to ensure the validity of machine learning models, particularly in terms of their robustness in critical edge cases. Data slice finding is an efficient method for validating machine learning models by uncovering potential issues on data subsets. However, achieving transparency and interpretability in slice findings often requires additional data information, such as metadata or cross-model embeddings. Moreover, domain practitioners still require additional support to comprehend why the model fails on these slices. Data augmentation is a popular approach to address model bias performance issues. However, collecting the right data to address a model problem remains a costly and time-consuming process. To address these challenges, we develop ConceptSlicer, an innovative workflow that leverages visual concepts and the knowledge from large foundational models to validate and optimize computer vision models. The workflow consists of 3 key stages. Firstly, ConceptSlicer finds underperforming data slices based on the model evaluation metrics and metadata generated using self-supervision techniques. Next, users generate natural language descriptions of the detected data slices by chatting with ChatGPT to support failure mode analysis. Finally, ConceptSlicer supports the users to query similar data from the supplementary dataset and retrain the model with the augmented data. The ConceptSlicer interface consists of multiple panels, including a slice browser, an image browser, a concept browser, and multiple cohesive functionalities to support this workflow. We describe 2 use case scenarios to demonstrate how ConceptSlicer helps identify various issues in the object detection model. The first use case demonstrates how ConceptSlicer can help alleviate model defects caused by complicated cases involving spurious correlations and object overlapping. We investigate an object detection model that detects objects of class horse. After importing the model performance data into the system, the user notices that the model has the worst performance on slice 1, defined by 2 absent concepts and a present concept. They check the suggested keywords and browse the sample images, then find that most images in the slice depict people riding horses on the ground without grass. They infer that there might be a spurious correlation between horse and grass. They also observe that in most of such scenarios, people overlap with horses. The detection boxes unavoidably include both horse and human torsos, which might cause the confusion for the model. Based on such inference, they instruct ConceptSlicer to request for scenario descriptions from ChatGPT for this slice. More specifically, ChatGPT generates scenarios with horses but without grass. They select the sentences with the most interesting scenarios that align with the prompt and direct clip to fetch the images corresponding to these selected narratives. Afterwards, they browse the retrieved images, remove the irrelevant ones, and export the supplementary images for the dataset augmentation and model fine-tuning. A new object detection model is trained on the augmented dataset. Our results show that the model's performance is significantly improved with the addition of the new images. The second use case illustrates the use of ConceptSlicer to augment the training set with images containing edge cases, thereby enhancing the model's robustness. When using ConceptSlicer to profile the car class, the user notices that the model's overall performance was not acceptable. They check the slice browser and discover that the underperforming slices were consistently associated with the absence of the same concept, 440. The vision language model suggests that this concept may correspond to car, truck, and TV monitor. Why does the absence of this particular concept have a recurring impact on the model's performance? The user finds the answer from the concept tree. This concept borrows significant relevance to a critical component of the car, the windows. In the majority of the slices where concept 440 was absent, the windows were either not visible due to their viewing angle, or because the cars were too small to discern the windows. To mitigate this issue, the user prompts ChatGPT to describe scenarios that involve cars, but where car windows are not visible, and gets some very creative scenario descriptions. ConceptSlicer retrieves relevant images in response to the prompt, which helps increase dataset coverage and improves the model's performance. In this work, we have shown how ConceptSlicer can help validate and optimize computer vision models through a unique approach where data slice analysis is guided by visual concepts. We evaluate our workflow through interviews with 8 domain experts and present both quantitative and qualitative observations. For more details, please refer to our paper.